Geometry IXL section R7 inverses of trigonometric functions. All right, so I'm doing this video because it was requested by one of my students that some of you guys are having difficulty doing this IXL also. First of all, let me tell you what this IXL is about in case you're confused or don't really get it. Um, when it says inverses of trigonometric functions, what that's talking about is this. All right. Remember that I said that there were three different types of trigonometric, no, three different types of trigonometry problems, basically. All right. And whenever they're talking about the inverses, they're talking about these keys, which you use them to find the measure of the angles. All right. So, in case you're unclear what this IXO is about, because it maybe the questions are not exactly clear, but what they're asking you to do is to find the inverses of trigonometric functions, and that's what you use when you're looking for the measure of an angle. All right. So whenever you have those, remember I said that when we did this in our geometry textbook, that was called the inverse of cosine, the inverse of sine, and the inverse of tangent. All right. You only use those buttons when when the answer you're looking for is what's the measure of the angle. Right. So hopefully that'll make some sense there. All right. And by the way, you could always, the way you would do these, I mean, I know the IXL is different from what appears different from what you're seeing here. But in case you need a reminder, the way you do these in your calculator is you would do 1.9 divided by 9.4 equals, and then you got to hit the inverse of cosine button. And remember that in order to access these keys, you got to first hit the second button to activate the secondary function of each button. Okay, so with that in mind, all right, let's look at the trigonometric ratios a second. In our geometry class, we only needed to go over these. In one of my video lessons, I talked a little bit about these other three at the end briefly, and I mentioned that there's a good chance you're going to see them in your intensive math class. All right, so let's look. Really, they should include this in our geometry class as well, but I don't know why they don't ask us to do it. But whatever. Anyways, they're basically the same thing. They're just the main thing I want to point out is that each of these three that we did not use in our regular geometry class is the reciprocal of the one on the left, okay? So here we have sine, and here's cosecant. Cosecant is the reciprocal of sine. Just look at what they're dividing. In sine, you do the opposite divided by the hypotenuse, and in cosecant, you do the hypotenuse divided by the opposite. All right, it's basically the reciprocal of this. Same thing with cosine and secant. They're the reciprocal of each other. And tangent and cotangent are the reciprocal of each other. By the way, this, in case you didn't understand me, cosecant, that's what CSC is. This one is secant, and this one is cotangent. It should be all together. I didn't mean to put a space there. All right, but these are the reciprocal of these. Okay, now, in addition to that relationship, let me show you another way you could also think about it. You could also think about it like this. All right, let's say you know what sine is. All you got to do is put 1 divided by sine, and that'll give you cosecant. Or 1 divided by cosine will give you secant, or 1 divided by tangent will give you cotangent. All right, if that doesn't fully make sense, don't worry about it. Give me a second as we start looking at some problems. Hopefully it'll make more sense, all right? But what I'm trying to point out is that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent, all right? By the way, trigonometry, yeah, it looks a little confusing. It's the type of thing that once you start doing it, you start getting it more and more, all right? So if at first you're confused, that's totally normal. It's only as you do more and more problems and you get deeper into it. In this class in geometry, we're only doing, this is all basic introduction to trigonometry. It goes way deeper. And you really got to do a lot of it for it to start fully making sense, all right? Now, let me explain something. Here it says Mr. U, special right triangles. I'm going to do an explanation on something that you don't really need in order to do R7, but it'll help clear up confusion and maybe help for things to make more sense. If you're not interested in my explanation on that, you could just skip the video, fast forward the video to the part where you have a calculator in the picture. Okay, that's where I started doing the examples from R7. Which, let me tell you, the examples from R7, you could totally do them all on the calculator. All right, so if all you just want is to get it over with, I guess you could skip to that. But if you want a quick explanation on something, it'll take me like maybe between 5 to 10 minutes, and hopefully unconfuse you a little bit. Then I would hold on and look at this. All right. Now let me explain something. There's a chapter in your geometry textbook. It's 13.3 on special right triangles that I skipped, and let me explain why. Normally, on a normal year, we do it. But this year, since all of you had to do the Algebra 1 EOC because you didn't do it the previous year, I had less time to teach all these things, and I had to make some strategic decisions in terms of what was going to be on the test, what you really need to know for our class. So I skipped this chapter. I wish I wish I hadn't, because it's actually a very important chapter. It's just that we were able to do the geometry test without even covering it. But that doesn't mean it's not important. This is actually very important. And it's very important, and it's actually simple. It's not difficult. Although I'm not going to lie, I'm saying it's simple, but every year I see some students struggle with it. I don't know why. I think it's simple, but whatever. Let's look at this. All right. It basically has to do with this. There's two special types of right triangles. One is a 45, 45, 90 right triangle, and the other one is a 30, 60, 90 triangle. These are triangles, like, this is referring to the measure of the degree of the angles, the measure of the angles. 45, 45, 90, and then in this one, it's 30, 60, 90. When you have triangles with those angle measures, there's a relationship between the sides that will always exist. All right? And R7 and R1, even though you don't realize it, they're actually using a lot of these triangles, all right? So look, there's two ways to explain these triangles. One way is with these X's. I think that makes it more confusing. Maybe I don't know if your intensive math teacher taught it this way or not, but I prefer to teach it. I just switched it, okay? From the X's using the number 1. I think that makes it way easier to understand, all right? Okay, so let's first look at the easier one of the two, which is the 45, 45, 90 triangle. All right, let's look at this a second. If you listen to me, I promise you I'll make it as easy as possible to understand this. Okay, so look, whenever you have a 45, 45, 90 triangle, notice that these are the legs and this is the hypotenuse. Notice that the legs, they always have the same number. Whatever number this leg is, this one will be the same. All right, so let's look. I put here just a bunch of 45, 45, 90 triangles so that I could play with them and make up examples. All right, so first of all, if this is 7, this one's also 7. All right, if this is 10, this is 10. If this is 99, this one's 99. If this one's, let me put something else. 2 square root of 5, this one's 2 square root of 5. You follow me? If this one's 13 square root of, I don't know, 2, this one's 13 square root of 2. All right, so that's the first thing I want you to notice, that the legs are always going to be the same measure in a 45, 45, 90 triangle. All right, okay, now with that in mind, now look at the hypotenuse. Okay, to go from the leg to the hypotenuse, all you got to do is multiply whatever is here by square root of 2, and that'll give you what's here. All right, 1 times square root of 2 is square root of 2. Let me make up an easy example, okay? Stay with me. Give me a second and you'll see that this is easy, right? Let's say this is 5 and this is 5. All right, to get the hypotenuse, just multiply this leg by square root of 2. That's it, I got the hypotenuse. If you do the Pythagorean theorem, you're going to get the same answer. When you simplify your answer, you'll get this same number, okay? I'm keeping the numbers simple, okay, for now. Let's say you got 7, okay, this will be 7 square root of 2. Let's say you got, I don't know, 3. All right, this will be 3 square root of 2. Okay, Let's say you got, now let me add some radicals to this, all right? Let's say you got square root of, let me not make it anything difficult. Let's say you got square root of 3, all right? All right, first of all, this leg, what's it going to be? This leg is the same thing, square root of 3. And I said to get the hypotenuse, you multiply whatever's here times square root of 2. So this will be square root of 6. Why? Because square root of 3 times square root of 2 equals square root of 6. Okay? Now, let's say you got, let me try to complicate it a little, slightly. I don't know, square root of, give me a second, sorry. All right, let's say you got square root of 2. Let's say this side is square root of 2. First of all, this side is the same thing. All right, the legs are always the same. Now, if I multiply this times square root of 2, you should know already that square root of 2 times square root of 2 is going to equal square root of 4, which equals 2. And as I've said in a previous video, the shortcut is whatever number is here, that'll be the answer. So you got that. All right, let's say you got square root of, give me a second, square root of 8. That's not really right. Hold on, let me change that. Let's say you got 2 square root of 2 here. So this will be 2 square root of 2. If you multiply this times square root of 2, 2 square root of 2 times square root of 2 will equal 2 square root of 4. The square root of 4 is 2. So long story short, this will be 4. All right, hopefully that made sense to you. Okay, now let's also go backwards now. No, I'm sorry, not backwards. Well, yeah, backwards. Let's say I give you the hypotenuse and you need to figure out the legs. All right? How do you go from this hypotenuse to the legs? Easy. Whatever is here, you divide it by square root of 2 to get the legs. How do I know that? Because what's the hypotenuse there is square root of 2. What's square root of 2 divided by square root of 2? 1. So whatever number is here, divided by square root of 2 to get the legs, all right? So let's say you got 5 square root of 2 here. All right, so to get the legs, I will just divide that by square root of 2. That cancels out, so this is 5 and this is 5. All right? Let's say you got, I'm trying to put in easy examples first, okay? So let's say this is 7 square root of 2. Divide that by square root of 2, and the square root of 2 cancels out. So that means that the legs are 7 and 7. Okay, let me make it not so easy then. Let's say you got square root of, I don't know, square root of, hold on, of 10. Let's say you got square root of 10. All right, so to get the legs, you divide that by square root of 2. What you end up doing is dividing 10 divided by 2, and you get square root of 5. So this will be square root of 5, and this will be square root of 5. All right. Let's say let me do like one more, and then I'll move on. All right. But hopefully you're understanding that. Oh, and I want to add one more thing to what I'm saying here that'll also help you understand. I don't know. Let's put. Let's say you got 2. Okay, I got it. Let's say this is 2 square root of 5. All right. So to get the legs, you divide that by square root of 2. Okay, now I don't know if you saw the video I did on R1 where I went over simplifying. So if I divide 2 square root of 5 by square root of 2, I got that, and I can't simplify that. However, I said in the video that I did for R1 that you cannot leave a radical sign in the denominator. So to get rid of that radical sign in the denominator, I got to multiply the numerator and the denominator by square root of 2. That way on the bottom, I'll end up getting 2, because square root of 2 times square root of 2 equals square root of 4, which equals 2. And I said the shortcut is just write whatever number is here. If they're the same, you just write the number that's here. That's the answer. Okay, and on the top, I would get 2 square root of 10. These 2's cancel out. So my simplified answer is square root of 10. So this side is square root of 10, and this side is square root of 10. All right. All right, and one more thing I want to point out, the almost of the answers in R7, okay, are going to be, let me backtrack a second. Okay, almost of the answers, you're going to notice until you get to the end, almost all the answers are going to be either 45, 60, 30, or actually, that's it. Almost the answers are going to be those three numbers, either 30, 60, or 45. Until you get to the very end, it starts giving you some different ones. And the reason why is whether you realize it or not, it's using these special right triangles in the questions. All right, let me show you how. Okay, so like when you have a 45, 45, 90 triangle, all right? You remember I said that whatever each leg has to be, the legs are the same number. So like if this leg is 8, this leg is also going to be 8. Okay, so I'm blanking out, sorry. So you'll get questions like what's the tangent of 1? Oh no, the tangent of you know what? Let me continue. And when I see the problem, it'll give me a better way to explain it because I'm struggling right now. And I'll come back and make the connection between what I just said. Okay. Let's look at. Oh, you know what? I put some examples from the book, from your geometry book. So let me look at this real quick. Okay. Find the measure of the unknown side. So this is a 45, 45, 90 triangle. If this leg is 2 square root of 6, so is this one. And to get the hypotenuse, you could just look here. To go from 1 to square root of 2, I got to multiply the 1 by square root of 2. So the hypotenuse would be 2 square root of 6 times square root of 2, which will give me 2 square root of 12, but I got to simplify the square root of 12. The square root of 12, I could break it up into square root of 4 times square root of 3, okay? And by the way, this 2 is out here. The square root of 4 is 2. So basically, my simplified answer would be 4 square root of 3. That would be the hypotenuse. If you didn't get that, you should look at my video for R1. I did a lot of examples there on there. All right, let's look at another one. Okay, so look, here they're giving us the hypotenuse. They want us to say what are the legs. So again, to go from the hypotenuse to the legs, you got to divide by square root of 2. All right, so I just do 10 divided by square root of 2. Now, I can't simplify it any further the way it is there, but I need to get rid of that radical sign in the denominator. So I multiply the top and the bottom by square root of 2, and that's going to give me 2 over 10. I'm sorry, 10 over 10 square root of 2 over 2. And the 10 over the 2, you simplify that, and it becomes 5 square root of 2. So this leg is 5 square root of 2, and so is this leg, 5 square root of 2. All right? All right, so here they're giving me the hypotenuse, and we got to figure out the legs. By the way, if this angle is 45 and this angle is 90, that means this angle has to be 45. Because if you subtract those numbers from 180, this is 45 degrees here. All right, so again, to figure out the legs, do 18 divided by square root of 2. I got to get rid of the square root of 2 in the denominator, so it's going to be that, which when you simplify the 18 over the 2, you get 9. So each leg is 9 square root of 2, 9 square root of 2. All right, I think I got one more like this, and oh no, that's it. Okay, so now let's look at the 30, 60, 90 triangle, okay? It's the same concept, but this is the relationship between the sides, okay? It's the easiest way to understand this is if we start right here, okay? The side opposite the 30-degree angle is the one side. The side opposite the 60-degree angle is the square root of 3 side. And the hypotenuse is the 2 side. Okay, so why am I pointing that out? Because look, okay, let me start off with an easy example. Okay, all these triangles here that I'm going to use to play with, they're in the same, the same orientation as this triangle. Okay, so let's just start with this side. Right? Let's say I got a 5 here. Okay, so look at this is like our template. Same thing with the 45, 45, 90. This is our template, right? So this tells me what's the relationship between the sides. So how do I go from the one side to the 2 side? I multiply whatever's here by 2, and that'll give me the hypotenuse. So whatever's here, I multiply it by 2, that's my hypotenuse. Okay, so let me keep it simple. Let me put something else here. 3. Okay, so if the side opposite the 30-degree angle is 3, that means the hypotenuse is 6. Because to go from this side to the hypotenuse, I just multiply whatever number's here by 2, and that's how I get the hypotenuse. Another easy number, if this is 4, then this will be 8. All right, that's pretty basic. You should be following me with that, okay? Now, how do I go from, if I got the one side, that's what I like to call it. I don't know what the technical term is. I mean, technically, it's the side opposite the 30-degree angle, okay? But once I know what this side is, if I want to know the side that goes with the 60-degree angle, how do I go from 1 to square root of 3? Okay, easy. I multiply 1 times square root of 3 to get what's here. Okay, so what I'm trying to tell you with that is this. Once you know the number of the side that's here, multiply it by square root of 3 to get the number of the side that's over here. So what I mean is this. If this side is 5, this side is 5 square root of 3. If this side is 3, this side is 3 square root of 3. If this side is 4, this side is 4 square root of 3. I'm using easy numbers. I mean, I'll complicate it a little bit in a second, all right? So hopefully that makes sense, all right? Again, the easiest thing to get is once you got this side, the side opposite the 30-degree angle, that's what I'll call the one side, all right? That's Mr. U's term, all right? So once you got the one side, to get the hypotenuse, you just multiply whatever number this is times 2, and that'll give you the hypotenuse, all right? And to get the side opposite the 60-degree angle, multiply whatever the one side is by square root of 3. Now I put easy numbers, all right? But the numbers could be a little more confusing. And by the way, okay, so hold on. Let me go back to this. So let's say, excuse me. All right, so let's say you got, I don't know, square root of 6. So again, to get the hypotenuse, you multiply whatever this is by 2. So this will be 2 square root of 6. And let me put some other, let's say this is, I don't know, square root of whatever, 5. All right, so this will be 2 square root of 5 because you're just multiplying whatever this is by 2 to get this side. All right, okay, and to get this side, remember I said multiply by square root of 3. So this side would be square root of 18. However, you got to simplify a square root of 18. Square root of 18, I could break it up into square root of 9 times square root of 2. Sorry that I'm writing diagonally. I don't know why I do that. Okay, so square root of 9 is 3, and I'm left with the square root of 2. So this side is square root of 18, but simplified, you would write 3 square root of 2 for this side, okay? Not square root of 18. All right, this side over here, I would multiply it times square root of 3, and I would get square root of 15. Which cannot be simplified, so that one I can leave like that. Okay, now to complicate it a little. They're not, it's easy when they give you this side, but how about if they give you this side or this side? All right, so let's start off, whatever. I don't want to spend too much time on this because we got to move on to R7. All right, but let's say they give you this side. To go from this side to this side, you got to divide by square root of 3. All right, so let's say they give you, let's say this can get a little complicated. All right, so let's say they give you square root of 5 and you got to figure out the other two sides. First, I got to change it to the one side by dividing by square root of 3. And remember, you cannot have that in the denominator, so a radical sign in the denominator. So to get rid of it, I do that. So I'd end up with 3 and a square root of 15 on the top. So this side would be 15 square root of 3. And then to get the hypotenuse side, I got to multiply whatever's here by 2. Wait, what did I just do? I'm sorry, I wrote that wrong. I'm sorry. Square root of 15 over 3. That's what I meant to write. And then to get this side, I multiply whatever's here by 2. And I would get 2 square root of 15 over 3. All right, look, I don't want to keep going because it'll... By the way, to go from the hypotenuse to this side, you divide by 2. So if this side is 10, this side is 5. And then to go from this side to this side, I multiply by square root of 3. All right, so let's look at 3. I'm trying to go through it quickly, guys. We could spend more time on this, but... All right, so I'll be done with this section in like 1 minute, and then I'll get to the R7 examples, all right? So look, here I got a 30, 60, 90 triangle, except now it's not in the same orientation, but the same concept applies. All right, so look, the side opposite the 30-degree angle, that's what I call the one side. All right, so they gave us this. So to go from the one side to the hypotenuse side, I got to multiply whatever's here by 2. So to get the hypotenuse, I'm just going to multiply whatever's here by 2. So the hypotenuse is 10 square root of 3. And to go from the one side to the square root of 3 side, I got to multiply whatever the one side is by square root of 3. So that's what I'm going to do. To get this side, I'm going to multiply this by square root of 3. So 5 square root of 3 times square root of 3 is going to equal 5 square root of 9 which is going to equal 5 times 3, which equals 15. All right, so this side is 15. All right, I think I got like 2 more examples like this, and that's it. And then I'll get to R7. All right, so here's another 30, 60, 90 triangle. Here they're giving us the hypotenuse. All right, so if we start with the hypotenuse, we need to go here first because you can't go from the hypotenuse to this one. You got to go first to the one side. So to go from the hypotenuse to this side, I got to divide by 2. So whatever's here divided by 2. 4 square root of 3 divided by 2 is going to give me 2 square root of 3. All right, so this side is 2 square root of 3. And to go from the one side to this side, I got to multiply by square root of 3. So 2 square root of 3 times square root of 3 is going to equal 2 square root of 9, which is going to equal 2 times 3, which is going to equal 6. All right, and I think this is, let me see. Yeah, this is the last example, okay? So in this one, they're giving me this side. They're giving me the side opposite the 60-degree angle, which is the square root of 3 sign. All right, so if they give me this, I got to first go here before I could get this one, all right? So to go from the square root of 3 side to the one side, I got to divide whatever's here by square root of 3. All right, so the 9, I got to divide it by square root of 3 to get to figure out what goes here on the one side, the side opposite the 30-degree angle. So I write that, and now let me get rid of the square root of 3 in the denominator by multiplying the top and the bottom by square root of 3. This will give me 3. On the top, I'll get 9 square root of 3. And then the 9 and the 3 simplify. You divide them, and you get 3 square root of 3. So this side is 3 square root of 3. And remember I said to go from the one side to the two side, just multiply whatever this is by 2. So if I multiply this by 2, I get 6 square root of 3. Listen, if you use the Pythagorean theorem, well, a couple things. Number one, in order to use the Pythagorean theorem, you need 2 of the sides to figure out the third side. In these problems, notice you're only getting one side. And with one side, I'm able to figure out the other 2 sides. All right, this is possible because it's a 30, 60, 90 triangle. Or a 45, 45, 90 triangle. All right, so, and, okay, let me see if I could go back to what I was trying to say earlier, but I kind of got stuck. Basically, because these relationships exist, now let me keep going because I can tell I'm going to have a tough time explaining it here. All right, so look, these are the problems that you have in R7, all right? And, let me first explain it with a calculator. When I explain it with a calculator, you're going to be able to do them in a second. I mean, seriously. Once you understand it with a calculator, you're going to be flying through R7. Okay, so remember for all of these, you're finding the inverses of trigonometric functions. So you got to hit that second button on your iPhone or on your calculator because we're going to be using these keys right here to find the angle measures. Okay, so for the first one, they're saying this is what cosine of x is. What that means is this. First of all, just so you like have a understanding what we're doing, all right? You have a right triangle, and let's just say this is x. We're trying to find out how many degrees is this angle. And they're telling you that the cosine of x is square root of 2 over 2. And they want you to use that information to find out how much does this angle measure. How did I know to put those numbers there? Because cosine, from the point of view of this angle, cosine is the adjacent side, which is this one, over the hypotenuse, which is this one. Okay, anyways, so let me tell you what you do in your calculator. Hold on, I'm just logging into my calculator. All right, so turn it sideways and hit that second button. All right, so in your calculator, all you do is this. 2 square root button, which is this one right here. So 2 square root button divided by 2 equals, and then hit the inverse of cosine button, which is this one. Hold on, let me try that again because I just got an error. Let me do it one more time. 2 square root of 2 divided by 2 equals. Okay, you get 45. You get 45. Okay, you get 45, and I'll say it again just in case anybody needs one more time, okay? 2 square root. Wait, let me do it also. 2 square root divided by 2 equals, and then hit the inverse of cosine button, and you get 45. Okay, now let's look over here a second so I could kind of like relate this to what I just went over about special right triangles. You know why you get 45 degrees here? Because this is a 45, 45, 90 triangle. Okay, this leg, we didn't need it, but this leg is the same thing. And remember I said that in a 45, 45, 90 triangle, whatever's here, to get the hypotenuse, you multiply times square root of 2. And look, if you multiply this by square root of 2, you get 2. For these problems, it's not really necessary to know what I said about special right triangles, but it does help to understand it, okay? But there are certain problems out there that you do need to know special right triangles, all right? Let's look at the next one. Over here, okay, so I'm going to follow the same process. In my calculator, I'm going to enter 3 square root divided by 2 equals, now hit the inverse of cosine button and you get 30. Remember that I said that your answers, most of your answers for the first, like, I don't know, like the first 80% of R7 is going to be 30, 60, or 45. And you'll see that's going to be true. Now look, just to relate it to what I just went over, if you got a 30, 60, 90 triangle, okay? So look, they're saying that the cosine, we had to figure out how much is this angle. And they're saying that the cosine is square root of 3 over 2. Now, if you saw the little explanation I did on special right triangles, all right, this relationship exists in a 30, 60, 90 triangle. And look, notice the numbers that they gave us. Imagine there was an x here. If this was x and we didn't know how much it was, okay, remember that in a 30, 60, 90 triangle, this is the relationship that existed. So when I put this in the computer, boomer moment. All right, when I put this in my calculator, when I put this into the futuristic device that I'm holding, all right, I got 30 degrees for this angle, okay? All right, so I'm just showing you that it all relates. All right, let's look at the next one. All right, so in your calculator, and by the way, let me write this another way because let me write it this way. All right, this is how I used to write it. And the reason they're not writing it like this, let me explain why. They're saying that the tangent of x equals this, but this is the way I would write it when I was like solving problems involving angle measures, because I thought this was the clearest way to show what we're looking for. We're trying to find the measure of angle x, and that equals, you got to divide square root of 3 by 3 in your calculator and then get the inverse of tangent. So that's, and by the way, let me just do this for these as well. All right, so the measure of angle x equals inverse of cosine. And this one was 45 degrees, if I remember correctly. And this one was the measure of angle x equal. All right. The reason they're not writing it like that is because they're telling you, hey, the cosine of x is this, so what must the measure of angle x be? All right. They're writing it correctly. It's just my way is more, I don't know, I think it helps you understand more like what we're doing and what we're looking for. Okay, so back to the one that I left off on that I didn't do, okay? So in your calculator, I would do square root of 3 divided by 3 square root divided by 3 equals, and then hit the inverse of tangent button and you get 30. Again, notice that all the answers, a lot of them are 30, 60, or 45. So, whatever, let me continue here. Now let me just use this. Let me go back to the special right triangle, just to show. So they're saying the tangent of 30 degrees is square root of 3 over 3. Tangent is opposite over adjacent. So if I put those numbers there, remember I said that the 30-degree side is the one side. And to get this side, you multiply square root of 3 times square root of 3, and look what you get. You get 3. So the relationship works. And to get the hypotenuse, you multiply whatever's here by 2, so it will be this. If you didn't see that explanation, it's not necessary. and just don't worry about it, okay? Okay, so I'll kind of lay off that for a while. All right, so for this one, we're trying to find the measure of angle x, which equals the inverse of sine square root of 2 divided by 2. So in your calculator, do square root of 2 divided by 2 equals, and then hit this button, and that'll give you the answer. Let me do it as well. We still got to go over the other trigonometric ratios, functions, which I'll show you right now in a second. All right, so when you do this, you get 45, all right? Let me put the answers for these two, because I think by now you should get it. All right, this one's 60, and by the way, this one was 45 degrees. And the last one, I would do, in the last one, you just put 1, and then hit the inverse of tangent button, and you get 45 degrees. And for that one, I am going to show you how that relates to the special right triangle so you can see something. By the way, for this one, in case anybody's confused by it, the measure of angle x equals the inverse of tangent 1, which equals 45 degrees. Okay, remember, if you saw my explanation on special right triangles, I said that in a 45, 90 triangle, 45 degrees and 45 degrees, all right, whatever, both legs are the same, right? So that's why, like, it doesn't matter what the legs are. Let's say they're 8 and 8. All right, tangent is the opposite side divided by the adjacent. It's always going to be the same number divided by the same number, which will equal 1. That's why when I got the inverse tangent of 1, I get 45 degrees. I could have put something else like, I don't know, 5 and 5. Again, 5 divided by 5 is 1. And when you get the inverse of tangent, to find the measure of this angle, it'll be 45 degrees. All right. Again, with trigonometry, it takes like doing a lot of problems for it to sink in. All right. I'm sure with this explanation, you mostly get it. But to really get it, you really got to get deep into it and practice a lot. Okay. Now look, on this one, now we got all those trigonometric functions that we didn't go over in our geometry class. All right. So you got to remember, this is the key thing. You got to, for all of these. Okay. First thing I want to point out is notice that, hello, we have no buttons for those. Those buttons are not in our calculator, in our futuristic device. They're not there. Golly gee, what do we do? All right, so look, this is where it comes into play that you got to know that they are the reciprocal of the other 3 trigonometric ratios. All right, so let me write them here. So sine, let me write here reciprocal. So look, the reciprocal of sine is cosecant. The reciprocal of cosine is secant. You know how I remember them? The one that starts with an S, the reciprocal is the one that starts with a C, and the one that starts with a C, the reciprocal is the one that starts with an S. Believe it or not, that works. Tangent and cotangent are the only ones that it's like obvious that tangent goes with cotangent. All right, so cotangent is the reciprocal of tangent. But for these two, just remember that they're the reciprocal of the one that starts with the other letter, not C, but with the S. Not S, but with the C. All right. Okay, so with that in mind, you know how I'm going to do this? Look how I'm going to do this, all right? So look, the measure of angle X, let me see if I could write this correctly in a way that makes sense. What I'm going to do, instead, to find the cosecant, how can I word this correctly? To find the measure of the angle whose cosecant is square root of 2, what I'm going to do instead is find the measure of an angle whose sine is 1 over square root of 2, because that is the reciprocal of square root of 2, and cosecant and sine are reciprocals of each other. I know that may sound a little confusing at first. All right, let me go over how to do it in the calculator. All right, and actually, I'm going to show you a button that we never use that you may find helpful. All right, let me just do it real quick to make sure, to refresh my memory, make sure I don't do anything wrong. Okay, look. All right, so here's a way, look at this button right here, okay? I'm going to give you the quickest way to do it, all right? By the way, do you see that button? That button says this. Basically, what you do is when you put in a number and then click that button, it changes it to the reciprocal of whatever you put in. So let's use it, okay? What you could do is put into your calculator square root of 2 by doing 2 square root. And then hit this button, and it's basically doing 1 divided by square root of 2. So it's giving you the reciprocal. After you hit that button, just hit this button, and you'll have your answer, which is 45 degrees. Hey, what do you know? I'll say it again. For all the people out there that are not necessarily Cobra Kai material just yet, okay? Hit in your calculator 2 square root. Now hit the 1 over x button, which gives you the reciprocal of the square root of 2. Now hit the inverse of sine button, and you get 45 degrees. Now you could have also done 1 divided by 2 square root equals, and then hit the inverse of sine button. But there's some, like when we get to, I don't know, I think when I got to like these problems, that made it a little tricky to put it into the calculator, and I was getting errors because it's very easy to mess up how you put it into the calculator. So it really is helpful to use this button, because basically, look, this is what I'm going to do for all these questions. I'm going to put in whatever it says here. Like when I get to these, I'm going to put it in the order that it says there, and after I put that in, I'm just going to hit that button, and then hit the button of the reciprocal trigonometric ratio. All right. If that sounded too complicated, let's just let me go through it. Okay, so let's do this one over here. All right, cosecant of x equals 2. So what I'm going to do is I'm going to find the measure of angle x whose the reciprocal of cosecant is sine. So whose inverse of sine is 1/2. Okay, in your calculator, this is what I would do. Enter 2, hit the reciprocal button, and then hit the inverse of sine button. And let me do it as well to see what I get. All right, so what did I say? 2, the reciprocal, inverse of sine, and you get 30 degrees. And you guys thought this was difficult. Look how simple it is. Maybe you just needed to hear it from your sensei, and now it makes a lot more sense. All right, let's go to this one. Let me erase everything. Let me not erase because we need that. All right, let's look at this one, all right? So look, you could flip it upside down and do it that way, but I don't know. I think it's easier to just do it the way it's there, right? So hold on. So I'm gonna find the measure of angle x, which equals, instead of secant, all right, let's do it from the point of view of its reciprocal, which is cosine. So the inverse of cosine, which is 3 divided. You know what? I'm realizing that, okay, I'm writing this out, but really we're going to do it this way in the calculator. You could do it this way as well. The thing is, when you put this in the calculator, hold on, what I'm trying to say is this. You could put this in the calculator, but it's kind of tricky to enter this, and even I was messing it up a little bit. All right, so I think the easiest way to do it is first put what it says here, which I'll go over right now. First put what it says here, and then hit the reciprocal button, and it'll change it to the reciprocal without you having to enter it this way. All right, and then we'll hit the inverse of cosine button. So let me walk you through it. So in your calculator, you're going to put 3 square root times 2 equals divided by 3 equals. Now hit the reciprocal button, which is the 1 over x button, and now hit the inverse of cosine button. Hey, you get 30 degrees. That's always a good sign that you did it right. If you get like a solid number like 30 after you entered all that weird stuff into your calculator. All right, so let me say it again. All right, 3 square root times 2 equals divided by 3 equals. Now hit the reciprocal button, which is the 1 over x button, and now hit the inverse of cosine button. When we hit that reciprocal button, it's basically turning everything we did here into this, okay? But with that radical sign on the bottom, it's very easy to enter it incorrectly and to get an error from your calculator. So that's why I'm like, I think it's easier to do it this way. And then after you've entered all of this in, hit the reciprocal button. All right, now let's look at this one. We're almost done. After this, I got like, there's, in the challenge zone, they have some different problems. that are actually easier than what we're doing here. So all right, let's look at this one. So this one will be the measure of angle x equals the reciprocal of cosecant is sine. So I'm going to get the inverse of sine 3 over 2 square root of 3 equals. Okay, so in your calculator, you're going to put this. Well, we just did it, basically this. So in your calculator, put 3 square root times 2 equals divided by 3 equals reciprocal button and then inverse of sine button, and you get 60 degrees. Whoops, 60 degrees. And then last one over here. Okay, so the measure of angle x equals the reciprocal of secant is cosine, right? So inverse of cosine 1 over square root of 2. Okay, so in your calculator, what you're going to do is put 2 square root. Now hit the reciprocal button, and now hit the inverse of cosine button, and your answer is 45 degrees. All right. Okay, almost done. I think this is the last page of examples. Whoops, messed up there. All right, this page. Wait, this one. Wait, we got 2 more or 3 more. All right, let me go through these quickly. All right, here, this is near the end, near the challenge zone. They start giving some that are not related to special right triangles. These are actually easy. Well, first of all, with cosine, tangent, and sine, this should be straightforward. You're just doing this. In fact, these I may not even explain. You're just doing this, or I'll explain it quickly is what I mean. That's what you're doing, okay? So you're doing, in your calculator, you put 0.4, and then hit the inverse of cosine button. And, hold on, let me do it. All right, so in your calculator, 0.4, and then hit the inverse of cosine button. And it says you got to round to the nearest hundredth. Okay, so this would be 66.42 is what you should get. I'll do one more, and then I'll move on to the other ones, because these are kind of easy. All right, so the next one, it says tangent of x equals 0.6, so 0.6. Enter 0.6 in your calculator, and then hit the inverse of tangent button, and you get 30.96. Let me do a few more. 3.6 inverse of tangent button, and you get 74.48. All right. So on these, again, for the top one, you're just putting 0 in your calculator. You just put 0.9, and then you hit the inverse of sine button, and you get 64. I messed this up. Hold on. 64.16. 64.16. Because again, what I'm doing is this. I'm finding the measure of angle x, and that equals the inverse of sine 0.9. So you're doing 0.9 and then hitting this button, and that gives you the measure of the angle. By the way, if you don't really get what that means is this. Let's say this is angle x, which I want to find out how many degrees it is. What this means is that when I divide, remember sine is opposite over hypotenuse. When I divide the opposite over the hypotenuse, whatever numbers are here, when I divide them, I get this, 0.9. And then I'm hitting the inverse of sine button, and that tells me how many degrees this angle is. Hopefully that makes sense, all right? So this one is cosine of x equals 0.7. So the measure of angle x is going to equal the inverse of cosine 0.7. So what that means is to find how many degrees angle x is, remember that cosine is the adjacent side, which is this one, divided by the hypotenuse. So this means that when I divide the adjacent side by the hypotenuse, whatever numbers are there, I get 0.7. So this is saying, hey, if you get 0.7, what must this angle measure? So that's why in your calculator you're putting 0.7. Okay, 0.7 inverse of cosine. And if I round it to the nearest hundredth, I get 45.57 degrees. All right, now let's look down here. I got secant. All right, so same thing we did before. Secant is the reciprocal of cosine. So what I'm going to do is this. To find the measure of angle x, all right, I got to do this. All right, let me try to explain this one the best I can, right? So look, let's say you have this triangle, this right triangle, and let's say this angle is x degrees. I want to figure out how much this angle is. Okay, what this is saying, secant is the reciprocal of cosine. All right, so we already know that cosine is the adjacent side divided by the hypotenuse, and secant is the hypotenuse divided by the adjacent side. So look, if when you divide the hypotenuse by the adjacent side, you get 1.1. That means that if you divide the adjacent by the hypotenuse, you get 1 divided by 1.1, whatever that is. All right, because they're the secant and cosine are the reciprocal of each other. Again, with trigonometry, you kind of got to do several of these problems before it fully sinks in. All right, with my explanation, you probably kind of get it, but to fully get it, you really got to do a lot of them, and then it starts to sink in. All right, so in your calculator, you do 1 divided by, or actually, my bad. Okay, you could do 1 divided by 1.1 equals and then hit this button, or you could do it the way we were doing it before, which is just enter 1.1 and then hit the reciprocal button. That gives you the same thing as if you would have done 1 divided by 1.1. All right, anyways, once you do that, now hit the inverse of cosine button, and if you round to the nearest hundredth, your answer is 24.62 degrees. So I'll say it one more time. In your calculator, you could either do it this way, which would be 1.1, and then you hit the reciprocal button, and then you hit the inverse of cosine button. Or in your calculator, you could do 1 divided by 1.1 equals, and then hit the inverse of cosine button. Both ways should give you 24.62 degrees. Let's look at like a few more and then I'll stop. All right, so right here, cotangent of x equals 0.7 degrees. This is the first time we use cotangent, so let's look at it. All right, so that means that the measure of angle x equals the inverse of tangent 1 over 0.7. If you got it, if you got it by now, you could leave, I guess. But but if you don't got it, I'll give the same explanation so that you can make sense of this. This is saying that you have a right triangle. You're trying to figure out how many degrees is this angle, which is x. Okay. Now, cotangent is the reciprocal of tangent. So tangent is opposite over adjacent. Cotangent is adjacent divided by opposite. All right. So this is saying that, hey, the cotangent of angle x is 0.7. When you divide the adjacent side by the opposite side, you get 0.7. So that means that if I divide the opposite by the adjacent side, I'm going to get the reciprocal, which would be 1 over 0.7. 1 divided by 0.7. All right? So you could do it two ways. In your calculator, the first way you could do it is in your calculator, put 0.7, then hit the reciprocal button, then hit the inverse of tangent button. Or the other way you could do it is in your calculator, do 1 divided by 0.7 equals, and then hit the inverse of tangent button, and you're going to get 55.01 degrees. I'm going to skip this one. Let me just do this one and to finish it off. All right, because I don't want to make this video too long. All right, so let's look at this one. Which one did we do secant already? Yeah, whatever. Let me do this one and then I'll be done. All right, so I'm just skipping one. You know what, guys? The the OCD in me is like, nah, don't skip it. It's just one more. All right, fine. Let me do both of these. All right. So for this one, cotangent of x equals 0.6. That means the measure of angle x is going to equal the inverse of tangent 1 over 0.6. So in your calculator, the quickest way to do it is put 0.6, hit the reciprocal button, and then hit the inverse of tangent button. So 0.6 reciprocal, and then inverse of tangent button, and you get 59.04 degrees. And then the last one, so secant is the reciprocal of cosine. So the measure of angle x is going to equal the inverse of cosine 1 over 2.7. Okay, so what you would do in your calculator is put 2.7 and then hit the reciprocal button and then hit the inverse of cosine button and you get 68.26 degrees. 68.26 degrees. The other way you could have done it is in your calculator, 1 divided by 2.7 equals, and then you can hit the inverse of cosine button, and you get, same thing, 68.26 degrees. All right, guys, that's it for this lesson. I hope this helps you out on IXL R7. All right, and if you ever have issues with your intensive class, feel free to ask me. Just try to give me time. Like you guys let me know about this like literally with almost like 1 or 2 days left before you got to hand in these assignments. All right, let me know what time, and I can help you guys out. All right, guys. Hope you guys have a great rest of your weekend. See you guys next week in class.